Everybody hear me? All right. Yeah, so I'm Phil from Apollo, and super excited to be here today with Luca and John from Doyensec, and they're leading security experts that have pretty deep expertise in GraphQL and distributed systems, complex code bases, that kind of thing. Doyensec actually led the Apollo router security audit back in 2022 when we were going into the V1 launch, and we just kind of continued our partnership, kind of working on new features of the router and stuff that came up like JWT auth and that kind of thing. So we really enjoyed working with them. And yeah, maybe before we dive in, just tell us a little bit about yourself, how you got started with security. And
sure, yeah, I can start. So my name is Luca. I'm one of the two Doyensec co-founder. Before Doyensec, I used to run AppSec for LinkedIn. Prior to that, a bunch of different jobs across consulting and product security. So I think I've been working and doing security testing since 20 years at this point. So I think I understand the space, enough. Yeah, me and John used to be colleagues at a small consulting firm that got acquired, and we thought it would be cool and also would make some money to actually bootstrap a security consulting firm, and we can go a bit into what that means, but
I'm John, hello. Marasano was the name of that old consulting firm we worked for. I worked for Accuvance, turned into Optiv, Yahoo. Yahoo created a red team, I was a part of that. And we started Doyensec in 2016. And here we are approaching 300 clients. And it's going well.
Awesome, that's fantastic. Yeah, so I mean, it sounds like you've done just a ton of work, kind of on the security front, working with companies like Apollo and, many others. So in all that experience, like what are the most common issues that you're seeing kind of come up, in these audits? And like, why do you think they're just so common still today? Like how come we just haven't figured this out? Like why do security issues still creep into our code bases?
Well, a lot of reasons. Well, I guess complexity is always, the main thing. Is people have different priority. Security sometimes is an afterthought. Those are reasons why security gets sacrificed. But honestly, it's also a matter of complexity and workload. Engineers have a lot to think about. Also, I always tell my clients that it's so much easier to break stuff than to build stuff. So it does require a different type of skill set, but I kind of feel like we have an easier job than our clients. So that would be my take.
Okay. And what do you run into, John?
It's interesting seeing the evolution of security over the years. When we first started, we would see cross-site scripting everywhere, SQL injection everywhere. Frameworks like React came out, and you see that cross-site scripting, for example, going away. It's rare these days, but we still find it. Been around for 20 plus years now. Good job, security. Yeah, as Luca said, complexity is the enemy of security. We find as an app gets more complex, we find different kinds of logic issues. If I could quickly talk about my favorite bug that we ever found, it's an interesting one, it's a logic one. Simple one, but it kind of shows what I'm talking about. We were auditing this grocery delivery service, and users can have a group order. So, you have this group cart happening. There's one person that pays for the cart. So when they elect to pay, a little pop-up comes up where they have to enter their credit card information to buy it. However, the problem was the other members of the group can still add things to the cart without that person seeing. So it's kind of a logic bug that you wouldn't really see with a scanner, you wouldn't see with a code audit. You have to understand how the app works, that the person paying doesn't know that the price is being increased because they can't see it. So that's my favorite bug, very simple, but that's my favorite one we've ever found so far.
Yeah, I mean, it sounds like security is pretty wide-ranging in terms of the types of issues that can come up. And I mean, just in general, it kind of is a wide-ranging concern from, dev all the way through into production. But, today we're really going to focus in on, security audits and, it's basically a much deeper dive into like, is a particular, implementation secure? And so like, when is a good time, to basically start thinking about a security audit? When should you actually start the security audit? And, like how long does a security audit, typically take and that kind of thing?
Well, you should start thinking about security as early as possible. And, specifically I'm thinking about, design review, thinking what you're building, thinking about the design of not only the feature, but also infrastructure that is going to host that feature. And then when you arrive to the implementation phase, that's when kind of security testing plays a role. If you are an organization that has a security team, that would be the best time to actually get your security team to work with you. Literally, like as soon as there is something that can be tested. Different stories with external security partners like Doyensec, where obviously, you want to maximize your return on investment. So you want to do a security audit where when the code base is stable enough that any vulnerability, any design issue can be mitigated and will actually end up being used inside the application. So I would say, start engaging a security company, consulting firm, maybe a few months ahead of the beta of your product. Generally, like good consulting company have a 6 to 8 weeks lead time. Like if you find a consulting company that is available from Monday, that's not a very good sign. There are not that many consulting company that do, specialize in product security that are, that can really give you a consultant from the next week. So start engaging them earlier. But when to execute the engagement, I would say when you have something that is, if not all full code complete, is at least a good approximation on what we'll be pushing to production.
Got it.
Yeah, and just some comments on that are, there are a bunch of compliance that drive security. We have a bunch of clients pursuing SOC 2 as an example, where you need a pen test to satisfy that. Most commonly, our clients have a pen test once a year. If they release new features, major features with a lot of code, they want to get that pen tested as well, so sometimes more than once a year. And there are also different levels to doing a pen test. Doyensec does not run any scanners. The work we do is manual. We will actually look at the code that is written, look at the logic, understand the logic of the application of the platform, go function to function, API to API, and find issues with that. So as a client, you should be aware what kind of company you're engaging, making sure you're not just getting a report from a tool, because it's kind of a waste of money.
Awesome, thanks, John. So it sounds like waiting to the last minute when your Supergraph's about to go into production isn't the time to start working on the security audit.
Exactly, yeah.
All right, cool. So I mean, Supergraphs can actually be quite large. So like, you might have, the router, you might have a bunch of subgraphs, underlying microservices, complex network, and deployments in Kubernetes and all that kind of thing. So like, how do you go about scoping, a typical security audit, for GraphQL? Like if somebody's, getting started with Supergraph, like do you, kind of go after a subset? Do you take like an incremental approach? What's the best practice there?
I feel like, doing a GraphQL security audit, it's actually not just limited to the graph. There is a lot of other components. So, there is obviously infrastructure testing that is not very different from, the traditional network testing. But specifically on, on GraphQL components, we would look at the configuration, so the complexity and the size of the infrastructure and the, number of routers and the configuration applied to that, the use of or not of custom plugins that would influence the number of person days that we have to allocate. Specifically because, as John said, it's manual testing, right? So if there is a lot more code, that obviously require more time. In terms of the size of the graph, the way we think about it is more about eventually what is exposed to the end user as for query mutation subscription. So those are the main numbers that we collect from potential clients at the beginning when doing scoping. Clearly, you know, with unlimited resources, you would be testing every single microservice, every single graph, but that's, you know, not possible in practice. So we tend to focus on internet-facing environment and what is exposed to the end user, whether it's authenticated or unauthenticated. So yeah, that's basically the initial metrics that we take, and then out of experience. Both, you know, like professional experience that we had, but also previous clients and previous engagement, we now tune the sides. And, you know, obviously it's our idea over an engagement, depending on what are the actual goals. You know, sometimes companies are interested in feature testing, so they only want to test a subset of the functionality, and sometimes they want to, you know, engage us for the full security product. So.
Yeah, that's great. So, you know, when you're looking at what you actually need to run a security audit then, you know, after somebody's decided to go do one, you know, what do you actually need to get? You know, is it just the external API? Do you need to go deeper into all the code? I mean, you're talking about going function to function. Are you going into CI/CD pipelines? Like, what do you need from all the involved parties to really make that audit be successful? Like, how much collaboration do you need from the teams and all that kind of stuff?
Yeah, good question. So we highly encourage our clients to give us code access. When you're contracting a consulting company, you're basically paying for their time. So for us to give you more output to make it worth your money, we can find way more bugs with code access than not having code access. We can get a lot deeper into the logic, into the back end, into how everything really works. So I highly encourage giving code access. So logistics before a project starts. We need code access, we need user accounts, multiple organizations to test IDORs between organizations. If there's special setup requirements, we'll need those. Maybe there's IDPs we'll need to set up. But basically that's the gist of it. Code access, user accounts is the staple, and then the specifics of the project from there.
Awesome, thanks, John. So, I mean, you touched a little bit about, you know, hey, we do like manual testing, you know, we kind of like look at these logic things, you know, but also, you know, a lot of us have used security scanning tools like Nmap in the past and the like, and you all even have like a GraphQL specific tool that does some pretty advanced stuff for like identifying points of interest and that kind of a thing on a GraphQL schema and a system. I think that's called InQL, but you know, like what are some of the limitations, you know, of those security tools and scanners, and is that something that you actually like use in your own audits as like one of the tools in the toolbox, or you know, do you just dive in and kind of like become one with the code and figure out where to go, and so yeah, like what are the limitations of the security tools, and what's the best way to use those?
Yeah, so I think there's different classes of tools. I would put Nmap separate from like security scanners, like code scanners. You know, we've tried many of the commercial scanners, so we're not fans of them. We don't use them in our testing. We haven't found one that can find good findings, pretty much. It's, you know, but Nmap is like on the side. Nmap is used to studying the network, the ports, give you information. Code scanners, commercial code scanners, we don't use those. InQL is a very manual tool. It hooks into Burp Suite, so it makes it easier to study the graph and to test different types of vulnerabilities in GraphQL.
So how did InQL get started? Like, and do you use it in your testing?
Yeah, absolutely. So InQL is basically a tool to improve the efficiency of our security testing, right? First of all, it's a plugin of a very common security tools. So, you know, generally security testers are already familiar with this tool called Burp. And this is just a plugin of that. And it makes it very easy to, you know, fetch, if introspection is enabled, fetch all the schema and replay request, do tampering of, you know, variables. Like it's really just an easy way to basically have a general purpose client so that the tester can focus on the business logic bugs. clearly you need someone that understands the security aspect. Is not a point-and-click tool. And I think the main limitation around security tool for GraphQL is, like limited support, but also the type of vulnerabilities in, modern GraphQL installation are things that are not that easy to detect with security scanner. Like security scanner have been kind of got the best out of injection bugs. So those are bugs where, you send a payload, you send a request, and because of, thanks to the error messages or how the application behaves, you understand whether the injection was successful or not. The reality is that most of the bugs on GraphQL are not injection bugs. So they just don't work for those other classes, those business logic. So
helpful, but not sufficient, basically.
Yeah, I mean, they do provide a baseline security. Every organization should probably have some scanners just to make sure, especially if we think about infrastructure testing, making sure you're not exposing, microservices, out on the internet. From a network layer perspective, those are things that are easy to catch with a standard, network scanner, cloud scanner. There are multiple vendors and standalone tools. But when it comes to actual application security, that's a different story.
Got it. So, I mean, one of the things that I've heard is that, like different security practitioners will actually have different styles or approaches when they're kind of running an audit. And so, and I can imagine if you're spending like a spaceship to the moon and, you want to have like triple redundant systems and you want to compare the results and all that kind of a thing. And so for even like, mission critical projects, if both of you are doing it with different styles, you might even uncover, and then if everything matches up, then you're like, oh, this is even better, right? So like, what's your personal style? Like, how do you approach, you're like, paratrooped into, a site and, you got to come up to speed on this complex code base in like a week or two, right? And then run all your tooling, identify the points of interest, and then generate, a report with best practice recommendations. So like, what's your technique?
It's pretty crazy if you think about it. We are expected to learn the code at least to the same degree or better than the developers that are making the code to find issues in the code in a short period of time. And it's very much based on the personality of the tester, I would say. So me personally, I like to use the app first. I hook it up to a proxy. Burp Suite is the most popular one that we use. See what kind of requests are being sent, what kind of data is being sent, and then just get a feel, very much become one with the app, get a feel for how it works, and then switch to code. See how the code is parsing the requests, parsing data, what you can do with it, how it's structured, how it works. And then I personally tend to, this is where me and Luca differ, I tend to jump around and sort of sniff out interesting places in the code to find things.
Got it. So kind of like genetic programming, right? You kind of hop over and you explore an area, and then you hop over and explore another area.
Exactly.
So
yeah.
That's super awesome. So what about you, Luca? Like, what's your technique?
Yeah, so we're very different on that, but and I would preface that with security testing. As to be honest, I think you also software engineering is not an exact science, right? You can build the same stuff in completely different ways, and sometimes there are multiple ways that are suboptimal, and maybe so there are standards. So we actually co-authored one of the standard testing guide that is like trying to formalize what security testing really means. But at the end of the day, I mean, there is a lot of like thinking outside the box and creativity that leaves room for personal styles. Personally, I'm more of I have a software engineering background, so I'm a lot more methodical in a sense that I would start from the code, extract all the entry points. So I like a top-down approach. Because on modern application, you never have time to audit the entire code base. So you rather focus on what's exposed externally and then go down to their implementation and to the function they implement, the function, the actual feature and functionality. So I would list out all the queries and mutation, for example, and then one by one kind of analyze maybe how they work dynamically with this tool that we mentioned, or look at the implementation of the code. And I think, we generally, as a company, do peer testing for this exact reason. Like, people have different approaches, and there is not a good or bad approach. It's a matter of combining those, ensuring there is coverage, right? You can have a more freestyle approach as John, but at the same time, still do tracking of the stuff that you reviewed, so you have a good understanding of what was tested. So when you combine different approach, then it's, hopefully when you get best bugs, and then you should spend time for reporting, which is generally security people and testers don't like reporting that much. But as I get older, I appreciate the heart of communicating the findings. Like, I think it's actually pretty interesting how there are different ways that you can explain a security bug, and figuring out exactly what's the right way to convey what's the root cause and how to mitigate would turn an okay security report into an amazing security report, because they are providing actionable guidance to the reader.
Yeah, that's super cool. So, like, what happens, like after the security audit's over? I mean, you have these recommendations. Do people typically go and address those, and do you retest that? And then do people want to kind of set up a recurring kind of audit, or do they put automation in place? And how much does the automation get you? Does it help establish a baseline and holding that, and the software is constantly changing, right? So what typically happens there?
That depends a lot on the security maturity of the organization. Most clients would come back at a certain point, do a security retest, and after that, we also give what's called a customer-facing doc, security audit summary, so that you can satisfy both compliance and kind of the security engineer needs. And I think, to be honest, this is the best way to think about a security engagement, trying to combine the compliance aspect that is, we all have, with actual security engineering practices. The more advanced clients do have tooling set up for avoiding regressions. So, for example, they would write SEMGRAPH rules for the bugs that we found. Sometimes they would ask us to write those SEMGRAPH rules so that they can make sure that the same bugs will not occur. And then as you start doing engagement year after year, you realize that you have a set of maybe weaker points in your app, you have security anti-patterns, and so you can start building out of this knowledge, and even preemptively start writing rules or tools that will try to mitigate those classes of vulnerabilities.
Yeah, that makes a ton of sense. So, in these recommendations, John, how do you figure out what the recommendation should be? How much time do you spend learning about new threats, new vulnerabilities? What's your general process for staying current on all the latest and greatest?
Good question. I think it's very much up to the individual to stay current on blog posts, new things that are released. As a company, we do several things. We offer 11 weeks a year for each person to do their own research. If they're motivated by some specific technology, we give them the time to look into it, come up with maybe find bugs in something, or just to learn about how something works. Every Thursday, we have a Best Bugs Day, where we have two people talk about some cool issue they found in some cool project that helps us a lot. We do internal presentations on different things. There's no one answer. It's a challenge. It's a hard thing to do, but we try in several ways to stay up to date.
Nice. And then what about you, Luca? What's your...
Yeah, it's the same thing. So I believe you cannot be a good security professional without keeping yourself up to date. And even 20 years in the security testing field, I do end up spending an hour every day reading blog posts. I think there is no way out. Things like InQL, for example, started from this research time. Oh, yeah. So just started as someone from our team was interested in GraphQL. Back then was a very, very new technology. Kind of felt the potential of the technology, was interesting enough to say, okay, let's spend time for that. and like look at this conference, right?
Yeah, absolutely. So maybe we can just kind of deeper dive a little bit, on something more concrete, like the Apollo router, audit. So, we did that, with y'all going into our V1 launch for Apollo router, and it really helped out on a number of fronts. So maybe just walk us through like how you approach that, how you engaged with the team, kind of like, you obviously walk through all the code, had a set of recommendations, that were addressed and that kind of a thing,
sure.
But yeah.
I will take my notes, so I'm not going to tell you. So first of all, the report, you can download the report from the Apollo website, the blog post. There's a blog post detailing the engagement, and also Doyensec, Doyensec.com. There is a research page. If you search for router, you see the report. And I would also say that, Apollo, with very few other organizations, are publishing the full reports of the engagement. I think it takes, real self-determination and real honest interest in security to show to your clients and future clients, the bugs that you have or you had. Because we all products, I mean, we test product every week, and all products have bugs, different severity and, at different times, but all products have bugs. So recognizing that and showing that there is a long-lasting effect from a security audit, we can talk about that in a second. I think that's the important part. So everyone, again, can look at the details of the engagement. It was a 20-person day, so generally a 20-person day's engagement is scheduled as a 2 weeks to people. As we mentioned, it's meant to help for peer review and knowledge sharing. In every engagement, there are also kind of out of scope or what we call scoping restrictions. So there are things that we don't consider necessary in our threat model. And specifically for Apollo, I think it's interesting because one thing that we realized was, do you want to consider the subgraph and the supergraphs as trusted or not? Do you have downstream services that you would consider as malicious? And in most organizations, that's not the case, right? So to simplify the engagement, we kind of consider those as trusted. And for example, there is one finding from this report that is technically very interesting. It talks about basically combining graphs at the router level and how, basically overlap fields that can lead to exposing the wrong data. But it was rated as an informational finding because of the threat model that would consider those as trusted.
And that's actually super interesting because, when you're dealing with the supergraph, that's calling multiple subgraphs, that can actually be used to create a lot of traffic. And so having that trust and having, potentially like calling subgraphs that aren't trusted and injecting information there. So there's lots of ways of securing the communication between the router and your subgraphs, whether it be with like request security or peer security if you're running inside Kubernetes cluster, with MTLS between your services, those types of things. And so, it was really important for us to like highlight that after you kind of pointed that out in the findings, what the best practices were. And, we had some of that in our docs before, but we kind of doubled down on that. So that was super helpful. Yeah.
And then, the audit was performed on a default configuration router. And in the core logic, so we focus exactly on what's the core logic and what you would normally get if you just go and deploy a router. So there is a lot of configuration and flexibility, but obviously when you do such audit, you're not testing a specific deployment, you're testing the product itself. And so we try to focus on what's the most use case scenario. Again, and you can read more details about methodology and details. The results were, we identified 6 issues. 2 of them were denial of service vulnerability. They were later on mitigated by features. I believe 3 of them were medium severity. So we have a ranking system from informational to critical. So there were no high and critical security. And I think interestingly, so there was an issue around cross-site request forgery. cross-site request forgery is a type of bugs where you basically, generally in the web, you expect the user to always make HTTP requests, but that's not always the case. For example, if you visit a page that has an image tag with a URL pointing to a different site, your browser will still make that request on your behalf. And so this class of vulnerability is basically used to trigger functionality that the user hasn't started. And router was vulnerable to this class of attacks. And you implemented a features that was then later on enabled by default that basically completely kills this class of vulnerability. So as a security professional, as a security engineer, it's pretty nice to see that like a small security audit can lead to security features that then mitigates complete class of vulnerability, because the impact on on all the application, all the website out there, it's pretty big.
Yeah, absolutely. I mean, we're going through that, and the router team really enjoyed working with y'all, and the feedback and the collaboration that we had. And I remember the CSRF prevention feature went in, that was enabled by default, and I think the security audit really helped us kind of double down on like the secure by default stance of the router, and really like laying a solid security foundation. And then our continued partnership, working on features like, the JWT, the JOT authentication and stuff like that. And we're just going to be doing like ongoing security audits of the router just to ensure it remains, like a secure GraphQL runtime. So yeah, it's been great working together, and, look forward to doing more of that. And, if we have a little bit of time left, we can open up to the audience for questions, but, if not, you can drop by the Doyensec booth and ask them over there. So
thank you.
Thanks, everybody.
All right. Thank you.